First of all, I noticed in this question, it is a solve question, not a proof question. I also notice here a double angle. And one of the things we looked at last week is when you see a double angle, sometimes they're questions that we've done as multi-revolution questions that we learned earlier in this unit, and sometimes we need to use our double angle identity. And the way that you can sort of decipher between the two is if you just had the sine 2x and everything else was numbers, probably you could solve that as a multi-revolution question. But if you have the sine 2x and another function, like we have the minus cos squared x here, then it makes the most sense to change the sine 2x by its formula. And if you don't know which one it is, try doing one way, and if things stop working for you, try the other way. And if you try the other way and things stop working for you, go back to the first. Like, this is sort of what, when mathematicians actually are trying to solve problems that are really hard, they try one way as far as they can go. And if it doesn't work, they try another way as far as they can go, and it doesn't work. And I can tell you a true story on the second take-home quiz that I just handed out to you. I pulled a question from somewhere that actually wasn't true. It was multiple choice. And I spent 20 minutes trying the way I would normally work, and nothing worked. Then I took another method, went with that and spent 20 minutes on that, and it didn't work. And then I went back to my first method and spent another 15 minutes, and then I tried my second method with a different thing and found out that the reason I couldn't get any of them to work is because none of them worked. But I went back and forth between strategies. So sometimes you're unsure what to do. You start with one strategy, you go for a while, it doesn't seem to work, you go back to another strategy, it doesn't work. You go back to your first strategy and realize you made a mental math error at the beginning. And that's why it wasn't working last time. But sometimes it takes that back and forth. The 1/2 and the 2 here are going to cancel out. And now I still have a solving question. I could change the cos squared to 1 minus sine squared, but that wouldn't solve the fact that this question has sine x and it has cos x. And the best way to solve these is by factoring. I factor out the cos x out of both of them. And that allows me for sure to solve this part. I know that cos x is equal to 0. And that I could solve. I know that happens at pi over 2 and 3 pi over 2. And over here, sine x minus cos x would have to equal 0. In other words, in order for that to be 0, sine x would have to equal cos x. And we've solved this problem before. There's a couple of ways you could do it. Either you could do it by observation. When on your pi plate is the x coordinate and the y coordinate the same? That's when it's both root 2 over 2. That happens at pi over 4. Because they're both root 2 over 2, root 2 over 2. It also happens in quadrant 3, where they're both negative root 2 over 2. So I like that. Or in blue, if you divided both sides by cos, then you would get tan x equals 1, which would give you those exact same answers. Something happened in the building over the weekend. Temperature in this room is set at 18. It's currently 26 degrees. Okay, questions to circle on this one are 12, 13, 14, and 15. Oh, and I finished the question, and in my head I reread it, but you should check your domain always at the end of your question. I normally solve between 0 and 2 pi. I solved between 0 and 2 pi, and luckily when I checked my domain at the end, it was solved between 0 and 2 pi. But if it was a general solution, you'd have to add the 2k pi. If it was a different domain, you might have to change your answers. And that's it